This is the last half-life calculation that I'm going to do as a video. It is a bit different than everything else. The second one that's in your notebook is very similar to what we did before in the previous videos. Again, you need to have this written on the bottom of page 64, and I'm doing this one out because it's a very different type of problem. We haven't encountered one of these yet. So it says strontium-90 has a half-life of 28 years. How long will it take for all of the strontium-90 presently on Earth to be reduced to 1/32nd of its present amount? Let's take a look at what they're asking us to do. Now here is the root of the question. How long will it take? So this is a time. This is a time question. Because it's a time question, I am not going to use the formula for the exponential decay function. So friendly reminder that this formula is only used to calculate mass in grams for us. You can do this number of half-lives, but we're not using it for that for this particular class, and it's not calculating time. Alright, so we're going to look at what we have. Strontium-90 has A, that's singular, half-life of 28 years. So T half represents half-life, and I'm going to jot down that one half-life is 28 years. We already decided it's time, and we want to know how long it's going to take for all the strontium-90 on Earth to be reduced to 1/32nd of its present amount. This fraction right here is something you want to definitely pay attention to. So I'm going to jot down this 1/32 or 32nd. If you take a look at this number, it's a fraction. We're doing half-lives with lots of fractions of 1/2. So could it be possible that this fraction is the result of multiplying 1/2 by itself a certain amount of times? And the answer to that question is yes, absolutely. So we're going to figure out how many 1/2s got multiplied to reach this particular fraction. So 1/2 times 1/2 is 1/4, times 1/2 is 1/8, times 1/2 is 1/16, and times 1/2 is equal to 1/32, right? So 1/2 is 1/4, times another 1/2 is 1/8, times another one is 1/16, and this one is 1/32nd. These represent half-lives. I'm going to just count them up. I have 1, 2, 3, 4, 5. So in order for this much of the radioactive isotope to be remaining, that fraction of it, 5 half-lives have passed. All right. This represents 5 half-lives. I guess I should write that down. If one half-life takes 28 years, we want to know how many years or how long it's going to take for 5 half-lives to pass. So I'm going to take this 5 and multiply it by the duration for one half-life, and you should get 140 years. Time problems tend to be pretty simple, but you have to think through what you have and what they're asking you to do. You want to be on the lookout for fractions that you can figure out how many half-lives are represented by the fraction.